Welcome to the IPv6 Buzz podcast, where we dare to dive into the 128-bit address space wormhole. Quick reminder, there's sponsorship opportunities available for IPv6 Buzz and all the other Packet Pusher podcast shows. So if you're interested, go to packetpushers.net/sponsorships and you can get all the details. And if you got something cool working with V6, we definitely want to hear from you. So reach out and let's get you on the show. I'm Ed Horley with my co-host Tom Coffey and Scott Hogue. And today we're going to be talking about sort of pitfalls and what to avoid with V6. And I think this is a great topic because often these are the first set of questions that we get from customers around, hey, what are the things that we should be avoiding? How should we be thinking about IPv6? And so there's a whole set of sort of discussion points that we think make a lot of sense for the audience, for you folks to sort of know when we're talking about V6. And we would love to hear back from you folks too, if you have ones that you think we should be adding to our list. But let's go ahead and jump into it. And I think the obvious one right off the bat is going into the mindset of IPv4 thinking, right? In terms of carrying over everything that you're doing with V4 and thinking all of that is applicable in V6. I think that's the biggest pitfall to sort of avoid because you just don't know enough about IPv6 yet from maybe how the protocol works and how to think about design. And so you just carry forward everything that you were doing with V4, assuming that that's how V6 is going to work too. I think that's a fair statement.
Yeah, absolutely. And we covered this in detail back in episode 102. I think it was dedicated entirely to IPv4 thinking. But whenever we engage with folks that are new to IPv6, it almost always manifests in various forms. And I think the one that the one that's the most impactful right up front is IPv4 thinking applied to IPv6 related to address space, right? And just like the whole tendency to think, well, I'm used to making sure that I don't waste host addresses in V4 by doing a lot of, VLSM, variable length subnet masking, subnetting of IPv4 prefix space, just to squeeze the most out of what little I have, or, the fact that it's not an abundant resource and hasn't been for a long time. And it's just super natural for, engineers and architects to just carry that mode of thinking into IPv6 and think, and then right away, the challenge of like, oh, I've got an entire interface identifier of 64 bits. There's no way that could possibly be something that I shouldn't be subnetting like right out of the gate. It's like, well, should I start using /80s or /96s? And, and I think the first, any amount of time you spend up front with IPv6, when it's new to you, that's that mode of thinking is just, it's really easy to fall into because that's just what you're used to with V4.
Right. Yeah. You don't know any different because no one has sat down and explained the whole concept of, the /64. This is right. This is the sizing. Don't bother changing that. Right. And so you think you got the whole flexibility of the whole 128 bits, I guess, right. In terms of design and how you think about it.
I like using /112s because it gives me 16 bits in the interface identifier. So everything is like a class B address, pretty much. Well, no.
Someone lock Scott up. That's wrong.
That's so retro, Scott. That's lo-fi IPv6.
Class B, V6.
Yeah, I like the 96 because we can stuff all the IPv4 in there and not have to worry about it. And so it all matches up. And so we can just repeat that for different prefixes over and over. So
we'll sit all the things.
Yeah, exactly.
That's right.
It's funny because you are going to see, and I guess this is a caveat that we should state, is that there are RFCs and transition technologies that do make use of prefix lengths that aren't 64s. But they're designed very specifically around solving specific problems in this space. And so don't be confused about what you're seeing from maybe an RFC that is used for transition purposes versus the use cases of how you should design your network for day-to-day use for V6 as V6, for V6 moving forward. I think that's a really important point because otherwise you can get confused and you'd be like, oh yeah, the 96 is completely legitimate. I should be doing this for, NAT64 configurations and for other areas. And that's not what the purpose was for those particular design elements. They were done for a very specific design and architecture to solve a transition problem and to give flexibility there, but not necessarily for how you would assign out VLANs in your network. Right?
Using /126s is totally IPv4 thinking, right? Because, you think, I use a /30. For a point-to-point link, I'll use a /126. and so, yeah, that works for the first couple of, and then you map the interface identifier to the last, octet of your v4 address. So you have like ::::::::::::::::::::::::::::::::::::::::::::::::::::::::::::::::::::::: : 2 : for the first /126, the second /1, and then it matches, .0, .1, .2, .3, on IPv4. And then your second /126 is 4, 5, 6, 7. And then your third /126 is where things get bad, right? It's 8, :::8, :::9, :::A, :::B. And then you're like, oh no, I don't have A's and B's in my IPv4 octet.
Right.
Yeah, that's right. Well, the other pernicious thing about it too is that if you start subnetting that /64, you can get away with it for a while, right? Stuff kind of works. And, none of us, I think, deploy networks in this completely deterministic way where we know everything that we're going to do before we do it. And we validated that all configs work. I mean, there's just really no realistic way to do that. And so we sort of proceed heuristically, and that's the thing about it where, it works for a while and then it stops working. Like you subnet something and you break some function of IPv6 that's expecting that entire 64 bits is set aside for interface identifier. Slack is a good example of that. And so how far down the rabbit hole you go with, using subnets of the /64 before it finally bites back, and then you have like a configuration that you can't make work and v6 isn't functioning, and then it's like, well, something wrong with v6 here. Well, no, it's actually a misconfiguration technically, and you didn't discover it until just right now.
Yeah it's I guess the thinking part is how critical it is to understand what you're actually gaining with v6 from a network space versus a host space. I guess that's the balance of what we're talking about, because we're so used to in v4, the tension between the two is playing with the sizing, right, of how many hosts you need in a given network, that you just don't have to think about that anymore, which is a really weird feeling for anyone who's an IPv4 network engineer. Like, I just don't worry about that anymore. So stop worrying about it. It's a constant tension or anxiety that exists for all, I think, network operators today that are so used to v4, and you just don't have those concerns anymore. So I think it's hard to jettison that from your head.
Yeah, absolutely. I mean, the slash, and that, of course, that extends beyond the /64 into the prefix space proper, right. Because the /64 is what we put on interfaces in general. But then as we move up to higher levels of summarization in the overall address space that we're numbering into, we've got these the basic currency of the site, the prefix of a /48 in size, the smallest routable prefix on the IPv6 internet, and just the like if you just even sort of dragging your IPv4 thinking along with you, the idea that, it's one thing to say, to finally get around over the mental stumbling block of I've got, 1.8 times 10 to the 19th addresses. I just don't have to worry about host addresses anymore. It's another thing to apply that same mode of thinking to the prefix space, because again, where you might be trying to summarize in order to, organize the network around what your particular topology is. And so, it's not the same scenario, obviously, as having 1.8 times 10 to the 19th host addresses, but the same paranoia about, over consuming prefixes, or I think more specifically, basically having prefixes that are held in reserve that, you probably will never number into. And then, just that's a sort of a function that's forced by trying to keep things aligned along nibble boundaries, which is something that we've recommended for a long time. But that just the idea that you're going to overconsume prefix space, and then, the reality of, you look at the amount of IPv6 that's already been deployed, the internet at large is hovering somewhere a little around 50% IPv6. And, we're like halfway there, and we've used 0.07% of the overall prefix space in the global unicast allocation of 2000:3. I mean, so not even 1/10 of 1%. of the prefix space of 48s that's available. So the v4 thinking, it's more than just host addresses, right? It's also prefix space, and it's really it's a mental hurdle that's hard to get over.
Yeah, vulnerability scanning is also v4 thinking. You think I'm going to scan all my subnets and all my addresses and all my subnets to find vulnerabilities. You can't, with modern vulnerability scanning products, they don't do the types of reconnaissance, that you can do otherwise. But, you get this tendency of thinking, I'm going to scan all my networks, or something like that,
Yeah. And I think in a carefully planned network, could be, depending on what you have, sort of set up, it could be incredibly difficult for someone to understand that concept, because if they're used to working on a relatively, smaller enterprise network, it's like, yeah, it's not a problem to scan my network. I can throw my address space in there and sort of figure it out. But I mean, just to Tom's earlier point, you may not be using mass swaths of your address space in v6. And so trying to guess what's happening next in terms of reachability for a particular prefix could be very, very difficult. And even limiting that just to a 48 could be a challenge. So I think it's thinking that you're going to somehow scan and identify all the hosts in a given network with that design architecture could be you're going to need some other tools to help you out to figure out what's going on. Some other insight or drop piece of information that helps you determine where hosts actually are, I think, is the way you might address that. But that's definitely a v4 thinking problem. I don't know what's the other v4 thinking problem that's probably that I think is gonna bite people is the whole NAT concept, right? Mm-hmm. And we haven't really talked too much about it, but it maybe it leads into our next sort of conversation point of another pitfall. But I think NAT is such a commonly used tool in the IPv4 tool belt, because we don't have enough v4 addresses, so you can't provide public v4 addresses for hosts. Even with a stateful packet inspection firewall, you wouldn't do that on any given network because you don't have the address space resources to do that, unless you're incredibly lucky or very early on in getting address assignments. And they're probably worth way too much money now to be splatting them around inside your network internally. So I think that's another one that is something that people are not comfortable with. I guess they literally are not comfortable designing networks that don't have NAT running around inside of it. Do you think that's a fair statement?
Yeah, they conflate the translation with the stateful filtering.
Right.
They think they're the same and they can't be separated.
Yeah,
that's really the mental block that I think people have, because it's so used to being done on the same device, the firewall.
Right. And we're talking all the way from the smallest devices, CPEs, all the way up to the biggest enterprises, huge firewalls. It's the same process. And so I think it's been very ingrained as a v4 thinking of this is the way you deploy networks, right?
Yeah. And addressing is all of v4 addressing in an enterprise is done based on that concept. We have private addresses and we NAT it to a few or one public IPv4 address. Completely
overload that one public address.
Yeah.
Everything's hidden behind it, and there shall be no other way to build your network. And this, and I'll be honest, that's a completely reasonable answer for the IPv4 realm, because of the constraints that we're dealing with there. Mm-hmm. It's just freeing yourself of those constraints is incredibly hard. Like watching the conversations that we go through, from in design exercises and, well, how do we do routing? Well, we do routing the way we do routing on the public internet. Like there's all those conversations of like, I don't understand, like, what's the delineation between what my enterprise is and what, the public internet is. And it's like, well, this is your prefix space. You can do whatever you care to do, and you can secure it in any way that you care to. You put these prefix ranges behind your firewall. You put these prefix ranges in front of your firewall, right? And I think that's a very hard thing for people to get over. They feel like Well, because it's a globally unique address, it has to be globally accessible, and there's no correlation between the two of those. And I think that's very much a carryover of v4 thinking of like RFC 1918 isn't accessible to my outside world unless I build a mapping for something, right? You don't necessarily have to do that in a specific way for v6, right? But you would still have a stateful firewall in front of it. So you're still building a mapping rule that basically, or a policy rule that says whether you can access something or not. It's just not written in a way that says that's maybe clearly delineated in the same sort of way that v4 does it, which is fine. I understand the pitfalls or the stumbling blocks that people have with that, but just don't let it ruin your design, right? In terms of what you want to do from a design element of getting v6 deployed. Don't think that your NAT is necessarily a key critical element of your design itself. So.
And we spent a lot.
And
go ahead.
You'll still do security functions like an outbound web content filter, which will be running as an outbound forward proxy, terminating the internal connection, creating a new external, TCP session, and stitching them together in a stateful way. Proxying is still valid in v4 and v6.
Yeah,
it has that byproduct of the net new external connection has a different source address than the internal connection from the client to the proxy. So it has that feeling that it's doing a NAT.
Yep. Right. But it's really a termination of a session and a start of a new session. Right?
Yeah. And you'll still use that security function in your v6 network, same as you do today with your v4 network. Just want to make sure your vendor supports IPv6 thoroughly. Yeah.
Well, I think we covered the v4 thinking side, but the NAT carries over to maybe our next pitfall, which is, and I think this is, we consider this a today pitfall. This may not be a pitfall in the future if certain things get fixed, but the pitfall today, we think deploying ULA is a pitfall for organizations, and there's a whole variety of reasons why, and we've covered these in some past shows. But I really feel like that's a pitfall that people should be avoiding, at least today, is deploying ULA, and especially if you're planning on deploying it in a dual stack network, that you should avoid ULA. And I think just as a general rule, we should be avoiding ULA, especially if you've got plenty of prefix space that you went out and acquired or were given. I don't see a lot of compelling reasons to use ULA, but maybe we talk about one or two, and maybe we talk about the specific pitfall around ULA.
We've covered it, in other episodes fairly extensively. But I mean, I guess just it boils down to the basic brokenness of ULA and dual stack environments. I mean, I think the great major swath of our listeners are not in a position with their own networks where they can really think about doing IPv6 only yet. And for the folks that are going through the cycle of having, deploying IPv6 using dual stack, it is it's a potential big gotcha that's sitting there in plain sight that, you go through the trouble of configuring your network with both IPv4 and IPv6 and you use ULA addresses, and then the ULA addresses don't get used because of the prefix policy table and the way that that's deployed in host OSs and server OSs. So that could potentially be a big rude awakening to go through all the trouble to do that. And then it's like, you look at your traffic graphing and it's like, there's no traffic over IPv6 at all. What's going on here?
Yeah. It's kind of an extension of the v4 thinking. When you're new to v6, you're like, okay, I'm going to design a network. Well, I see my global addresses. Well, where's my v6 equivalent of RFC 1918? Oh, vendor tells me it's this ULA address space. Oh, okay, that makes sense. I'll approach v6 the same way I do IPv4. I'm going to do this ULA addressing. I'm going to NAT it at the firewall. It's the same thing I've done for IPv4. Feels natural based on, 20, 30 years of v4 experience. Oh, okay, this makes sense. And then they realize,
in the pit of despair.
It's not working out. They're like, oh, the first thing they'll run into is, with ULA, I only get a 48. That's like not enough. Or that's a site's worth of addressing.
Yeah. And what I find very amusing is, well, people want to use the ULA side. They pick and choose what they want to use out of ULA from the RFC. So they don't want to conform to the randomness that is required in the RFC.
Yeah, they don't create the 40-bit random number. Yeah.
Right. Which is okay. I get it. I'm just as bad. Like when I'm doing examples, I just grab the first one. So I don't go through and build the random. But that's for example purposes in a lab. If you're really going to deploy ULA, and you're serious about it, you should be following the RFC to avoid potential collision domains. If you ever have to merge a network with someone else, if you have to exchange information with someone else, then in theory, that's one of the advantages you get out of the randomness that was placed in the ULA RFC. And then I think if that's an advantage, I don't know. And then the other thing that you need to realize is that the whole issue, the crux of the issue is actually, as Tom mentioned, RFC 6724 is really the source destination address selection problem, and ULA is less preferred than IPv4. So if you're running a ULA and IPv4 network, your traffic will happen over IPv4, even though you may be publishing DNS records and providing all sorts of resources for doing ULA. And even if you had a NAT translation for working for IPv6 to translate your ULA out to a global unicast that you have on the front side, the mass majority of your traffic will still occur over v4 just because of that preference that exists in 6724. And there are pushes right now in the IETF to fix this particular issue. And it's going through all the review and everything else that needs to happen for the IETF to actually, make a change happen. And there's lots of complex conversations that are happening in there. If you want to follow it on the mailing list, go enjoy. Yeah, that is definitely a big pitfall, and it definitely correlates to the IPv4 thinking, as Scott mentioned, because it really is just a carryover. You want to deploy ULA because you're carrying over your v4 thinking, as opposed to deploying global unicast addresses, which is what pretty much everyone in the industry on the v6 side recommends that you do.
Yep.
All right. So I guess one of the things that that isn't necessarily a technical issue, I guess. And Scott, you brought this one up, and maybe you want to cover this for the audience. But I think it's not really a technical issue, right? It's more of a different type of pitfall that you might see organizationally as you try to adopt IPv6.
Yeah, what we've seen at a lot of extremely large enterprises is that an IPv6 project may start within the networking team, and they may charge ahead and deploy IPv6 maybe in pockets, maybe internally, maybe in isolated little environments. They may be rolling out IPv6 unbeknownst to the security teams or other teams. So I guess the broader concept here is that maybe one team would be more further ahead in their IPv6 understanding and implementation experience than other teams. Maybe the cloud teams further ahead with deploying dual stack infrastructure, and the internal teams, the internal networking team hasn't quite caught up, and now that cloud team wants to do something hybrid. Or the networking team is further ahead and the security team is behind. And then now that networking team wants to connect IPv6 through the internet perimeter out to the internet, and there's a firewall in the way. And the security team is like, well, what's IPv6? Like, I'm uncomfortable now that, the networking team is further ahead. And so if there's situations in an enterprise where one team is further ahead than another, it causes problems. Teams need to be moving at the same pace. Often, it's recommended that you build an integrated project team, an interdisciplinary team of folks from these different, roles and responsibilities or technology silos, get them to work together more effectively. But that's one thing we've seen as a pitfall for many organizations that causes the project to halt at some point while other teams get caught up.
And it really comes down to an organizational socialization thing of saying, like, we need participation from all the different aspects of the organization. Because I've seen this on on the other side of that too, which is sort of the client and server side of being like, wait, you're turning on what? And we don't really understand or know much about this. We're writing, we're building and deploying services all the time, but we don't really understand how V6 fits into what we're doing versus V4. And like, does every service have to be V6? And like, how does this impact how my client behaves? And I don't really understand what V6 is doing, which is very analogous, I think, to what you're pointing out, Scott, which is a lack of participation early on makes people automatically want to say no as a response, right? Mm-hmm. We need you to participate and do this. We've already thought through all these design elements. And I'm not saying it's bad for a network team to go through and do some critical thinking around the design and what they want to do. And from a big picture perspective around maybe the size and scope of what they need to support. So an address plan to Tom's, sort of, wheelhouse there, right? You have to have an overall view of that. As a network team, you probably have a much better understanding of what's required there. But if you don't talk to your security team, they may want to, take the opportunity with what you can do with V6 and suddenly deploy, overlay services, right? Overlay capabilities across the network. And they may want a whole swath of address space to be able to support maybe some new features or functions that they have in mind that they want to deploy over the long run. If you never have that conversation, you're not going to know about that need, right?
Yeah.
You're leaving them out.
Yeah. One of the public examples of this was the U.S. Government Accounting Office did a review of the U.S. Department of Defense's IPv6 mandates and their progress or lack thereof. And they created a report in 2020 citing that one of the key issues that limited DoD's IPv6 deployment success was getting security teams, security personnel trained, engaged, working on security as part of the network deployment of IPv6. And so, making sure that understanding the threats, properly protecting against those threats, was a key element that was missing in deployment strategies that prevented them from, making more progress.
Yeah, that's a great point. And in our day jobs, I think we see this on a recurring basis, both for federal organizations and large scale enterprises and all the way down to the smallest shop. It's a recurring problem that we try to address up front, right? Of trying to really build something that's collaborative as a project that covers the entire company, because networking doesn't, the networking protocol doesn't sit in isolation with just the network team running that, right? It's not useful that way. So services have to be plugged in. They have to be secured, right? And that's the key element that seems to be forgotten as many people try and tackle this problem. And they think all the decisions can be made by the network team in isolation to sort of adopt V6. And I think this is a great mistake. You can deploy V6 across your backbone and in a whole slew of your network and never actually turn a client device on. Right?
Yeah, I have seen several. One very large government organization has the most beautiful OSPF v3 network. Unconnected to the internet.
That's right. Untouched by user traffic.
No router advertisement. No. Yeah, the only IPv6 packets on that network are hellos.
For routing exchanges.
Yeah, and I've seen that in two very large, Fortune 100 enterprises.
And it may have been what's been running since like 2012 or something.
Mm-hmm. Yeah.
Well, that he got his CCI. That was his CCI practice. he got it all figured out, and it's working great. Right?
Yeah. We checkbox. We have 100% IPv6 deployed.
That's right.
It's on every router.
It's on every router.
Well, to Ed's point, you couldn't, looking at through the other end of the telescope, you couldn't have invented a protocol more, that would be more conducive to forcing a cross-functional initiative within an enterprise or, a large organization that's trying to deploy IPv6, just the division of the network with the server host side and having to bring those two together, and then when you add security to the mix, it really does just force the issue of if you don't have a good cross-functional initiative chops built into the organization, you're going to run into those headaches because of that, lack of all singing from the same hymnal on IPv6. And to be fair to the security teams, the types of initiatives that they're dealing with related to, trends and like trying to figure out what zero trust is and get to that, move in that direction, and how much that, sort of suggests or implies microsegmentation and actual, real world policy that boils down into actual configurations and where V6 fits into that picture. It's not, there's a lot of moving parts and you could be forgiven for like throwing up your hands and saying, well, I'm not going to show up to those V6 meetings because I've got so much on my plate already that, I really, one more variable is just, that's going to be the straw that breaks the camel's back. Having said that, don't be surprised when you find yourself in the hot seat of being the one individual or the one team that's holding up the entire IPv6 initiative and being called onto the carpet to figure out how to fix that and move forward.
Yeah, I think, network access control NAC, was plagued by, with failures of enterprises who failed to deploy a NAC solution probably couldn't get it off the ground because it involved cooperation between desktop, network, systems, and security. And the same thing is true of zero trust. To get that type of initiative designed and deployed, it requires a cross-functional team.
Well, and V6 fits in the same category. And I think it also exposes every single bit of political faction that you have within your organization, which is why it could be a huge pitfall of not getting people involved, because what you're doing is you're exposing the raw nerve of everyone saying you refuse to work with me, or you're holding back information, or you're doing, these horrible things, or you're not a team player. Like all those things manifest themselves the longer you wait to get involvement and as part of that initiative. All those things are going to happen, and being really clear and concise and, managing upstream to your project, to your superiors about what's going on with the project, and then managing downstream for your technical teams to understand the things that they need to accomplish and how they need to work with their vendors and to vet things and everything else. So that's a challenge. Like that's a skill in and within itself. And that's, so don't have any misconceptions, but just like any complex, multifunction, set of services that you need to deploy in your organization, you'll run into this problem. And V6 is just yet another example of exactly that. So, yeah, just another pitfall. I think we outlined quite a few of them, you guys. I'm super curious to hear what the audience has as additional pitfalls around this, and we would love feedback around that. So if you've got some, we would love to hear it, especially if you have, practical, real world experience of running into pitfalls around V6 deployment and adoption, whether that's dual stack or whether that's single stack, either one. We'd love to hear it. Well, you can reach the IPv6 Buzz podcast on Twitter at IPv6 Buzz. And you can also hit up each one of us on Twitter at IPv6 Tom, at Scott Hogue, and at E. Horley. But, to be honest, Twitter or X or whatever the heck they're calling it these days seems to be having challenges. So we really appreciate it if you head over to packetpushers.net/FU, which stands for follow up, just to go ahead and drop us any questions, comments about the shows, pros, cons, things you're liking, things you don't. I can't change the quality of my voice, so just you're stuck with that. But and a quick note, we've got a new logo for the Packet Pushers, and you should start seeing that rolling out in the next few weeks, and specifically for our show too. So we want to mention, so you're not surprised if you're in your podcast, favorite player and you're like, why is that yellow thing showing up? Well, that's our new logo. Thanks for listening to the IPv6 Buzz. You can find us on the Packet Pushers or any of your favorite podcast apps. Just search for IPv6 Buzz. And if you like the show, please give us a rating on your favorite podcast app, and please recommend the show to friends and colleagues. We would appreciate that. And if you like this podcast, we recommend you check out Heavy Networking, Day 2 Cloud, Network Break, and, all the other great technical content over at packetpushers.net. So long, and until next time, we'll see you on the internet. The IPv6 internet, that is.
Thanks for listening to IPv6 Buzz, a podcast devoted to truth, justice, and 128 bits of address space. IPv6.